Hi everyone, thanks for joining us. Hope you had a great long weekend. And hey, Eric, thanks for joining us all the way from Atlanta, Georgia to be with us here today. Eric, now you're a software engineer specializing in cloud security. Can you share with the audience like how you got into the security industry?
Yeah,
You've
I
got a
kind of
really
stumbled
interesting
into
story.
it. It was, I came into a job with a very strong software engineering background. I was expecting to interview as a software engineer, and I ended up getting offered a position as a DevOps engineer. And my reaction to that initially was, well, what's DevOps? I learned a lot about how DevOps works, how everything in the cloud is pretty much software, and how my skills as a software engineer apply a lot to the cloud. Eventually, I found that security plays a major factor in everything in the cloud. And here I am, just really fell in love into security, and now I'm a cloud security consultant, and I really enjoy it.
And you've also got a very interesting story, I guess, which has stuck with you during your time when you first started.
Yeah,
Can you tell us a bit about that?
yeah, definitely. Before I worked at my current position at ScaleSec, I was a DevOps engineer at a startup. This was I want to say like maybe 4 or 5 years ago. I'd be given a task to basically create like a testing environment in the cloud so that it can easily be provisioned and easily be torn down. I figured it would be a pretty simple task because I was pretty comfortable with the command line by that time. And as I've said before, everything in the cloud is software. So if I can program it, I figured it to be an easy task. Everything, basically, to give a little background on the what I was working with, the application that I was to create an environment for has been manually provisioned in the cloud. That means everything was kind of point and click in the console. All of the configuration for the environments were set up in Amazon Web Services, their Elastic Beanstalk service. And so all the secrets were up there, including all like the credentials and application configurations and so on. So I started writing scripts on a CI/CD tool you may know called Jenkins. I actually was able to create an environment just by creating some simple configurations in there, just some simple, almost one-line code, essentially. And so everything was going good. It was great. Then there was the part of the task. Yeah, what can go wrong? I mean, I've created the environment. I think things are running good. I've done my tests and everything looks good. What goes wrong though is when tearing it down, I accidentally fat fingered a command. Essentially, what I did was I put a flag, and it was just like a dash all or something like that. And I found that actually not only destroys the environment that I've created, but also destroys all the other environments associated with that exact same application.
Oh gosh.
Yeah, and so all of the environments, meaning the dev environment, the test environment, the stage environment, and the production environment, all went down along with my testing environment. So the outcome was pretty bad. I had to get on a call with my manager. First, he thought I was joking. He was like, "There's no way you did this." I'm like, yeah. I brought down not just production, but staging and dev and test. And we've created that by hand. So there's no code for us to quickly spin it back up or anything like that. So he's like, all right, well, we have a big problem now. Let me get on the phone with the software architects and engineers. We'll try to piece this together. So we were on a conference call with.
Yeah, go ahead.
Yeah,
Go ahead.
we were on a big conference call, and just everybody was kind of scrambling to figure it out. One developer would be like, "Oh, I have the latest code," and then another one would be like, "Oh, I have the credential that you need for this," and another one would be like, "Oh, I have these credentials," and so on. And we would all piece it together right back in AWS. We got production back up eventually, and after a little bit of stumbling, and then we got our staging and our test environments back up after a few, several hours actually it took to get everything
That's really
back up
quick.
eventually.
That's fairly quick to rebuild your environment. And it sounds like you were able to play the intern card to kind of get out of the situation. And it sounds like you also made some friends by buying everyone dinner in the aftermath of all that.
Well, I definitely owed people some beers, that's for sure. But it was a good experience. I was still new to the job and everything. Luckily enough, we were a smaller company, so we were agile enough to at least, kind of know who to talk to kind of bring things back together, which is how we got everything kind of working again. And yeah, it was a blameless postmortem afterwards. We figured out, well, what went wrong here? How can we improve? And we're not going to blame you for it. It's also other people's fault. People gave you access to do this. We didn't have proper backup procedures and infrastructure as code and all of this, and hence the two major topics we're talking about today, which is one, my account had too many privileges and we needed to make improvement in our identity and access management. That's the IAM part of it. And then two, we need a better way other than pointing and clicking in the console or doing like ad hoc scripts like the one I was making, and instead adopt proper infrastructure as code, which is IAC, which is our second topic. So yeah, that's pretty much it.
Well, one of the things I love about the security community is that everyone's just so open about sharing their experiences, and I think as a community we become stronger by sharing our experiences with other people, so that it's great to learn from your own mistake, but it's even great to learn from other people's mistakes as well. So before we jump right into the topic, if you guys out there listening, thanks for joining us, and please pop down your questions in the comment section below. I'll be able to ask Eric throughout the presentation and also at the end of the presentation. So please pop them down there. I'll be able to see it. The other thing is just to rewind, take you back a few weeks. How this topic came about was I put a poll on LinkedIn and I asked people, hey, what topics are you guys interested in hearing about? And number one, you guys said it was cloud security. Give me more cloud security. So here it is. Eric's given us a little bit of a spiel about why today's topic is so important. What could go wrong if you basically do the opposite? So please, without further ado, please go ahead, Eric, and share with us today's presentation.
Definitely. Thank you, Stephen. Appreciate it. And I'm excited to be here with the cyber risk community. So I'll go ahead and start. My name is Eric Evans. I am a senior cloud security consultant at ScaleSec. We've already done our intro story, but just to talk a little bit more about myself, as I've said before, the lessons learned from that kind of guide my career. It was pretty much like a turning point in many ways. Now I'm working smarter, not harder. I'm currently a cloud security consultant at ScaleSec. Previous to my job, I was a DevSecOps practitioner at a number of startups. And before that, I was a software engineer. I have over a decade of experience in IT and security. I also sit as a member of the board and director of research and development at the cybersecurity nonprofit. Please check us out if you're interested. We have plenty of cybersecurity topics, and we are a global community. My specialty is in Amazon Web Services and Google Cloud Platform. I've earned several certifications for these public clouds, and I also have a certification in HashiCorp Terraform, which is an infrastructure as code tool. I'm also an organizer for the HashiCorp user group here in Atlanta, Georgia. So over the years, I've become versed in infrastructure as code and DevSecOps best practices. So I'm going to go ahead and introduce our topics for today. I'm happy to share our lessons about infrastructure as code and identity and access management, which is, again, I think two of the most important topics in cloud security today. For infrastructure as code, we're going to go over like the best practices and how it actually relates to cloud security. And then we'll finish up with identity and access management, where we will also go over the best practices and figure out some tips on how to achieve the principle of least privilege in the cloud. So as far as infrastructure as code, I think I've mentioned a little bit before, is everything in the cloud is turning into software. So in order to create infrastructure at scale, it's impossible to do it without automated templates or programming language to express how you want to interact with your cloud service provider. So since everything is moving to software, security definitely starts at the code, at the infrastructure as code. Everything should be defined as infrastructure as code, with little or no exceptions. You can see on the right-hand side of this slide is like a typical kind of like infrastructure as code pattern. The cloud practitioner will write the code, produce a plan, and then that can be approved and apply to whichever cloud you're working in, whether that be like AWS, GCP, Azure, Kubernetes, and then the code provisions resources in these clouds in a specific fashion. So you have a definition of your infrastructure that goes through a process, and then that eventually gets applied to the cloud. So it gives you structure, and it allows like many folks to kind of like contribute and see what's going on with the infrastructure as well. So it helps out with the openness and the visibility.
It also gives you an audit trail, right? Like an audit trail of what's actually happening in your environment, and to also recreate it if things were to go down.
Yeah, absolutely. Yeah, it was very applicable to my experience. You get to see why people made the choices they made as well, and then what the current state of your infrastructure is. And if you're doing this with proper Git flow, you can see, oh, well, the staging branch looks like this, the test branch looks like this, the master branch looks like this, and so on. And so it's very easy to recreate environments and make dynamic environments as well, which is what I was trying to accomplish in the first place. So yeah, it's a very more modern approach to security and infrastructure than the old way of like having like just your security only requirements. Your code is of course stored in the Git repositories. Those can be shared with whoever you want to share code with, even auditors that are technical enough, who may be trying to attest your infrastructure for things like PCI or FedRAMP or CIS benchmarks. ISO 27000 kind of comes to mind. If they're technical enough, they would be able to look at your infrastructure and see how how basically your code is your documentation for your infrastructure in many ways. So it helps to foster like a good DevSecOps approach, since there's many eyes on potential security events that could pop up during the development lifecycle. So you put everything kind of through a process as you would your actual software. So in that way, infrastructure as code kind of facilitates security services with APIs, basically policy as code, versus the old school mentality of like mandated security controls and paperwork. So you can see kind of like on the left here, there's an excerpt of HashiCorp Sentinel, which is another language which is used for the policy as code that goes hand in hand with your infrastructure as code. And in this particular rule, it makes sure that you don't deploy firewalls that are open to the public. So you can see how we define our CIDR block range, the 0.0/0 range. And what infrastructure as code allows you to do is kind of have this go through the process. You check it in version control, you perform a plan, which will check your infrastructure against rules that your security team can define, which is kind of like what we have here on the left. And then if they pass those checks, then it's approved to be applied to the cloud. So this helps to ensure that security happens at the rate of DevOps in a very frictionless way to kind of achieve security in the cloud in an open way, in a very highly adaptable way as well.
So this is like basically a automated way to just check for simple things or simple errors of configuration.
Yes, yeah, absolutely. And simple at first, but they build on top of each other and they can become more complex over time. But not complex in the way that the rules are managed, but more complex in the maybe robust is a better word. The rules can become very robust over time. So now there's a lot of infrastructure as code tools out there. I showed some Terraform so far, but there's also like CloudFormation, Deployment Manager, Ansible, Chef, Puppet. There's a lot of different ones out there. If a big part of being secure in the cloud is using infrastructure as code, you want to make sure you have the right tool. So I'm going to go ahead and give some opinions on what I think makes a really good infrastructure as code tool. To start with, you want your infrastructure as code to be declarative and not procedural. So what this means is that when you write code, you want code that specifies your end state, and then you want to let the tool figure out how to achieve that end state. This is different than code you would write to simply like make a change on your infrastructure, like you would say, add a server, add another server, add another server. Instead, say I want 3 servers. You're kind of declaring it instead of imperative. If this doesn't make sense yet, I'll go ahead and show you what it looks like. So here on the left, we have HashiCorp Terraform. It's a declarative infrastructure as code language. And on the right, we have Ansible. It's imperative infrastructure as code language. And if you look at the first stanza here of Terraform, it says we want to create 10 EC2 instances. And it's the same thing here on the right. We want to create 2 EC2 instances. It's not too much different yet. The difference happens when you want to change. So let's say we want to upgrade to 15 servers. Well, for Terraform, you simply change your count to 15, and then Terraform will figure out how to achieve that 15. On the right-hand side, you'll see that the count is 5. So the reason why is you've already made 10 servers. Now you're saying I want an extra 5. Thus, your code changes to 5. And then if we want to go to 25, we say count is 25 here for Terraform. But for Ansible, you go back to 10 because 5 plus 10 plus, 5 plus 10 plus another 5 is 25. And there you go. I mean, it basically, what you're seeing is an imperative language creates more complicated code base, which increases the likelihood of misconfiguration happening or security incident happening, because someone will look at the code and say, oh, you only have 10 servers when I actually have 25 servers happening. So that's,
basically, it sounds like it's a longer audit trail because you have to step back and see what's happened from the start of your code to see what's happened.
Yeah. Yes, absolutely. Yes. That more complicated code base comes with a longer audit trail, and it just takes a longer time to kind of piece together the what needs to happen. If you go back to my story, if I was trying to piece together, okay, well, this application had how many servers again? Maybe I scaled up and scaled down many times during a particular period. I'd have to go back into Git history and see all of those different things because I don't have a state file that will help me out with that. So another thing about infrastructure as code I wanted to talk about was how it should be brought through the entire software development lifecycle process. So you want to employ regular testing on your infrastructure as code, just as you would your software. This includes unit tests, integration tests, functional tests, end-to-end tests to ensure that your code, which is going to declare eventually what's going to be in your cloud, is going to do what you want it to do and behave in the way you want it to behave. So in the example shown here, you can see a pull request in GitHub can trigger a Jenkins job. The Jenkins job will block the pull request from being merged into the main branch until it's validated and testing has been performed. So the tests will need to be done, and then the results of the tests will determine whether or not this code can be merged into your code base. And when it's merged into the code base, we're assuming here that it's going to be deployed to your infrastructure. This will either allow or disallow changes to be made until these checks have been performed. So this is a really good way and very essential to reducing risk of misconfigurations in the cloud and making sure that you don't have like open firewall rules, or you don't have a server that has missed patches, or maybe it's not using the latest AMI. AMI meaning Amazon Machine Image, the image that is used for the virtual machine, and so on. Those types of misconfigurations can be found before they're even deployed in your pipeline using infrastructure as code. Another thing I wanted to mention is differentiating between configuration management and infrastructure as code, because these get conflated from time to time. In my opinion, they're definitely not the same thing. Provisioning infrastructure is simply setting up your your base services like virtual machine instances, load balancers, and databases, and so on. The applications run on top of those instances. Those should be handled by a configuration management tool. So in this diagram that you can see here, Terraform has provisioned a virtual server in the cloud, and Ansible, which is a configuration management tool, uses a playbook in SSH to configure the server. So the software running on the server should definitely be treated separately than your infrastructure as code, which is kind of giving you the base that everything else is running on. So that's one just something to keep in mind when looking for infrastructure as code tools, is to kind of be sure you can differentiate between the two. Another kind of example of that is configuration management tools tend to make changes. That is, like, mutate your infrastructure and causes your servers to become different than others. This leads to misconfigurations and security vulnerabilities, because you're changing servers, and these servers have a different, they've deviated from the baseline in many ways. You've declared your infrastructure to be one way, and now they've changed in another way, and they're essentially like not managed the same way that the others are. This phenomena is known as configuration drift. So your configuration is drifted from the baseline. So instead of mutable infrastructure, it's best if you have a infrastructure as code tool that does immutable infrastructure. That is, whenever a change is done to servers, it tends to replace those servers rather than simply change the servers that are currently employed. So this helps with patch management, since you don't have to pull the latest, or so you will have to pull the latest machine images whenever they're booted up. And then it helps to ensure that you don't have a drift in cloud infrastructure as well. Another thing is, in some of the infrastructure as code tools, they utilize agents. So you want a tool that's considered to be masterless, that is not having a server that's kind of controlling the rest of the servers. If you run like a master server to control your infrastructure as code, you increase risk with extra exposure and extra maintenance. And to break that down a little bit, for extra exposure, you'll have one or more master servers, if you want to do like high availability, that would need to be exposed to talk to your agents, which is all of the servers that you're managing. And you would have to open up additional firewall ports, additional authentication systems to kind of get everything working right. You could pretty much see where the risk comes in with that, because you have an increased attack surface. And then for maintenance, you have to be able to back up these servers. You have to be able to upgrade them. You have to be able to patch them regularly. So that's all security risks that you're introducing to your infrastructure management system if you're using one that has to do this kind of relationship. And then I'm going to break down.
So what you're saying is there shouldn't be some sort of dependency on a master server to communicate to the outside world, but they should be independent in a way.
Yes, yeah, absolutely. Your infrastructure as code should be, or your infrastructure shouldn't have a dependency on other infrastructure being at a specific or controlling that infrastructure, if that makes sense. Your code should be the source of truth, not necessarily the configuration of the master. And that's all agents does, right? So your agents are installed on the servers, and they talk to the master server. So you also have to worry about bootstrapping those agents, meaning that more packages are going to be installed on servers, which means greater risk. You have to worry about maintenance on those. Each agent has to be in sync with each other, or else a misconfiguration can happen. Because if you have one server with an agent that's not communicating with the master server, that master server may consider that server offline and say, okay, if you want 3 servers, this server is offline because he can't reach the agent. So I'm going to go ahead and deploy a server to replace that one. So risk can actually happen from that as well. So yeah, you have to open up ports, figure out how to authenticate, and so on. Just bottom line is to choose an infrastructure as code tool that doesn't have that server agent relationship. Basically, the advice is to choose one that leverages IAM, which we will get into in a moment, to interact with resources in the cloud. Cool. And now I guess we're going to get onto the subject of identity and access management. IAM is extremely important in cloud security. I'd put it higher than things such as even network security in many ways. You'll hear me mention a lot about the principle of least privilege, and that's would like to open up with on our IAM discussion. It basically means that you only want to grant permissions that are needed to perform a role or a task. You don't want to grant any more than that, and if any additional permissions are ever needed, only grant them on a case-by-case basis. Be sure to monitor carefully, revoke the permissions when they're not needed anymore. So it's all about just kind of keeping track of is this account privileged or not, and keeping a close eye on those very privileged accounts. And hand in hand with that is not just the users who are using your cloud system and the autonomous users that are also like the computers and machines that have to assume IAM roles to perform actions, but also how you structure your cloud. And depending on the cloud, it's called either accounts or projects. But as far as that structure goes, you want to keep them small and plentiful. This limits blast radius, essentially. So if something does go wrong on an IAM level, your entire cloud is not going to be affected. If your projects are small, only that small project would be affected, hence blast radius. So definitely consider separating individual applications into their own accounts and separating all of your environments. This includes like dev, stage, prod, QA, UAT, whatever you may have. And whatever you do, don't put everything into one project. You know, it makes it hard to limit access when everything is in one project. You want to make sure you have a lot of smaller projects. In order to kind of like craft your IAM policies, because your policies is what you are basically a collection of permissions that you're giving your identities access to perform. You want to use cloud native solutions like IAM Access Advisor to help view what services are being used by what users and roles. So for instance, if there's permissions that you've granted to a user that they're no longer using, like for instance, if they have access to let's say they have access to like RDS, which is a relational database service, and they're not using those permissions, it would be recommended to remove those permissions to follow the principle of least privilege. And thus, if that account is ever compromised, it doesn't have the ability to do things that it wasn't already doing. So there's no, it helps with making sure there's no lateral movement whenever things like that happens. And it helps to limit that blast radius that I've been talking about a lot as well. There's also open source tools like Policy Sentry, which is made by Salesforce. Parliament checks for least privilege as well. There's a couple of others too I didn't mention in the slide, but there's Aardvark and RepoKit by Netflix. All of these programmatically check for least privilege, and they use tools like the IAM Access Advisor to figure out what your IAM roles are doing, and then remove any or advise against or even block permissions from happening. That just goes against the principle of least privilege.
Did you say Netflix has a solution here for people to use?
They do. Yeah, they have an open source solution. Netflix actually has a lot of open source projects that are used. But yeah, I'll be happy to share that with you guys if you ever want to.
There you go. Revenue diversification.
Indeed. Yeah, you have to think companies like that manage cloud at scale, and so they have it's common to have internal tools to help them achieve that kind of scale. and Netflix was just nice enough to open source some of that stuff for us.
That's super nice, super nice.
Definitely. And these tools, they check for the existence of syntax like wildcards that I show over here with like an asterisk. Basically, you want to avoid those at all costs because they tend to over permission things. So the example I give here is like S3:*. That means I can read, create, update, delete objects. I could do all of that, and I could administrate that bucket using IAM just because I put the little star. Perhaps I just want to do read only. Perhaps I should only be reading and writing to it, and I shouldn't be changing the bucket at all. You definitely want to just enumerate instead of using these wildcards to ensure least privilege in your accounts. And here's an example of kind of the account structure I've been talking about. It gets a good visual representation. So you can see here, there's separation between like your dev, your stage, your prod, even the DevOps and infosec accounts are separate from each other, and so are the logging and the KMS accounts. And then interesting in this is the IAM account. So what you would do in this case is you wouldn't have access to any of the other accounts directly. You have to first authenticate into that IAM account. And then once you're in that IAM account, you can assume roles, and you can see the green and red hats here to kind of show you the assumed role here. You assume roles to go into the other accounts. So what this does is gives you one central account where you could manage all of your identity and access management, and then use that account to authenticate into the other accounts as well. And this is a great way to manage privileges within a centralized location, and also keep a good audit trail in one location as well, to see who's opting into what accounts at what time, and so on.
Does this also touch on single sign-on when you talk about being able to authenticate from another account?
Yeah, absolutely. That's exactly what I'm talking about. You would use single sign-on like SAML or OAuth to actually go into other accounts like that. So yes. Yeah. Let's see here. So a great thing about the cloud is the fact that so many people can innovate in it and create resources really fast and perform a lot of actions and kind of like bring things to market fast. It's important to like facilitate that growth, but kind of like in a controlled manner. And I know I've been talking a lot about like least privilege and stuff like that. All of this is kind of saying you want to employ security controls that don't limit innovation. And in order to do that, you kind of want to set guardrails. You kind of want to control that growth in the cloud. And I have two examples on this slide, since again, I'm an AWS and GCP expert. Unfortunately, I don't know what Azure provides. The first one is AWS service control policies. And what they do is set a maximum amount of permissions that your accounts can have in your organization. To visualize this, you can see the Venn diagram on the left-hand side, and you can see the intersection of a service control policy and an IAM policy. That intersection of those two circles, your service control policy and your IAM policy, is what you can actually do in your AWS accounts. And then the second one is for Google Cloud. That's the organization policy service, and it's very similar to SCPs in the fact that it can set restrictions over what can be done in your cloud. And you can see on the graphic on the lower right that your organization policy administrators, which would typically be like your security team, can create and apply constraints that help regulate GCP services. So this gives developers kind of like an easy way to like do as much as they can, but eventually they'll hit those guardrails and they'll just know to kind of like stay inside, you know. And if those need to be adjusted, security team can then make exceptions as needed or make some tuning as needed. everyone I've ever encountered that uses these has had to do some tuning of some sort to see what's right for their organization. But it completely depends on how you want it done. And this is an easy way to do this without just denying everything at first and then giving it an approval process that builds up. Instead, you just have guardrails to kind of like make sure people stay in line. I think I've also mentioned during my story that we had secrets kind of scattered all over the place. So there was, the folks on the conference call who were also, logging into different services and being like, oh, here's the API key that we have for this, and so on. A great way to solve this is by using a secrets manager. And so secrets are simply pieces of data that gives you access to other data. And it goes hand in hand with identity and access management, because a lot of times these secrets are credentials. And that's why I wanted to mention it here. You can implement a really good secrets management solution like AWS Secrets Manager or GCP Secret Manager. There's also robust open source solutions like HashiCorp Vault. You can see the flow for Vault on the left-hand side. That shows that the security team creates Vault policies, and these policies manage access control for secrets, depending on who has authenticated into Vault, into the system. And so you can use this to kind of like set fine-grained controls to see not only what people have access to those secrets or have access to manage those secrets, but also what applications have access to those secrets and have access to manage those secrets, and so on. So I've written a few blogs on the subject that I highly recommend for reading. I've done a comparison of AWS secrets managers back in October, and then I did one just a while back for comparison of GCP secrets managers. Definitely check those out. I highly recommend those reads if you want to learn more about secrets management. And then also very important is monitoring of IAM in the cloud. So for AWS, there's Cloud Trail, which monitors all the API activity that goes on in your account. And then you have cloud logging in GCP. Both of these are used to monitor IAM events. These pair well with their associated tooling in the cloud, which is AWS Guard Duty and GCP Event Threat Detection. That kind of detects anomalous activity, such as like over-granting access or granting access to like unknown accounts. You could then respond to these detected threats by using serverless functions like AWS Lambda and Google Cloud Functions to kind of create event-driven architecture to automatically react to behaviors of interest. These functions can also send alerts to your team to make sure that they're aware of whenever an IAM event occurs. You can even monitor secrets and credentials to see how, when, if they're being used. It goes without saying that you should rotate secrets regularly. I wanted to make sure that was covered as well. So putting it together in an example to kind of like demonstrate how all that can work together. What happens here is a user updates a security group, which is basically a firewall rule, and it opens it up to the public internet on a management port. The user, in order to do that, has to use IAM to perform that action, which creates a log, an audit log in CloudTrail. CloudTrail will then trigger a CloudWatch event, which is listening for that event to happen, which in turn causes a Lambda serverless function to automatically close the firewall rule. So it automatically does like remediation of that automatically. And this is all happening within a matter of seconds because of how fast the cloud works. Because that change has been detected and Lambda went in and fixed it. They could then use the SNS service to alert the information security team and say everything has been remediated. This is what happened, and this is who did it. And then the security group has been already fixed, and so on. And by the time your team looks at it, they're like, okay, well, they can see what happened. So you can create a powerful architecture that keys off of IAM events in the cloud. And as we're getting closer to the end, I just wanted to note that IAC and IAM interact a lot with each other. In order for your IAC to work, it needs to assume permissions to perform actions in the cloud. And just like any other IAM roles you have in the organization, permissions should follow least privilege. and make sure that they only have access to the accounts that they're managing infrastructure in. Everyone should use that single pipeline to provision infrastructure, so everyone gets those same set of security checks. You don't want folks who are special who can do it outside of the pipeline and not go through those security checks. You want to make sure everyone can go through those same security checks for a variety of reasons, compliance being one that comes to mind, saying, hey, all of my infrastructure goes through these checks first. How can you demonstrate that that's happened for all of your infrastructure as code? All right, let's go ahead and wrap it up with some key takeaways. Definitely do your research on infrastructure as code tools. I hope my advice that I've given can help you through that process. Be sure to employ it throughout your organization as well. Cloud security is only going to work when everyone is doing it. Use infrastructure as code in that single pipeline to ensure your proper security testing across the board. Follow the principle of least privilege to limit impact of any compromise. Again, it's all about ensuring your identities have access to only enough permissions to do their job. For instance, if I'm a data scientist, I shouldn't be managing firewalls. I shouldn't be managing web proxies. I should have access to databases and other analytical services. Create guardrails via policies to manage your IAM at scale. It's all about keeping the agility of the cloud front and center, as well as security, front and center. And finally, make sure to monitor your environments to detect IAM risks. You can start building use cases and event-oriented architecture to kind of look for risk in the cloud, detecting cloud misconfigurations, and then having a great detection and response strategy for those risks is a very effective way to achieve risk management in the cloud. So there's so much more I wanted to go over today, but I hope this is a great overview of infrastructure as code and IAM, and I hope that you've enjoyed it. Be sure to follow me on Twitter, LinkedIn, GitHub, and my blog. Thank you, everybody.
Thanks. Hey, Eric, thanks so much for sharing that. If you don't mind, we'll just go through some questions now from the audience. You may have answered this later on in your slides, but just as coders often repurpose functions and other snippets of code from others, what do you think about the idea of internal Git repository or equivalent to hold the pieces of IAC for certain purposes? So for example, you have highly competent code that describes a database, app server, or web stack, complete with storage and compute instances. Yeah,
I think that's the way to go. Having an internal Git repository with well-documented infrastructure as code helps other folks who are in other departments, perhaps, or maybe they're not involved with the project that you're currently working on, kind of jump into the code and start building rapidly in a secure way when combined with a secure pipeline. So I think that's a really good idea. And breaking out your code into individual repositories and not just one repository helps with that too. You can say, oh, if you want networking code, it's in the networking repository. If you want compute code, it's in the compute repository, and so on. That's definitely good.
Just split them up. Got it. So for a genuine escalation of privilege where employees are supposed to get a higher access for X days to do some task, usually there is a ticketing permission system. How do we integrate that permission system with IAM? Basically, can we automate real escalation of privilege versus malicious escalation of privilege in IAM?
That's a really good question. Everything in the cloud is software, and I will say that many, many times. And along with software, they use APIs to communicate with each other. So ticket provisioning systems nowadays have APIs that can plug into different software, either using JSON, REST, XML, whatever it may be. And you combine that with the IAM systems in the cloud. I mentioned HashiCorp Vault a few times. It's good for brokering access as well by using kind of ephemeral service accounts or ephemeral IAM permissions or roles. And these roles will be highly privileged. These are the ones that that you want to use for a little while, but not forever. So I can see a flow, and I think I've built a couple of flows like this, where it would take that ticket from the ticketing system once it's been approved will then change the vault policy to allow that individual to retrieve credentials, temporary credentials that can be used to perform highly elevated actions, which then comes with audit logs through the vault audit log, and then have that token with a time to live that is only for that amount of time that they've been approved for in the ticketing system. So yes, that's how you would do it. You definitely want to use like a broker like Vault in order to achieve that with your IAM.
And so some of the software and tools available are getting really good to help with automation. So that's really good to hear.
Yeah.
You also mentioned, I remember throughout the presentation, something that stuck with me was use Terraform, I believe, for building up your code. I think if you have, because I know people who traditionally become security engineers come from a network background. So they generally go from a network background, and all of a sudden they've got to transition into become, managing the cloud infrastructure. Right. What would you recommend for those type of people who are going from network into cloud? What kind of things should they do to sort of adjust to the new operating environment?
Right. So learn a programming language. I think that's always a good start. At least just knowing the foundations of how programming works kind of get you closer to understanding how the cloud works with software, and how to not only look at individual network activity and looking at it from a networking perspective, but also looking at it at scale and how software can like enable that scale and so on. So I would highly recommend just grasping network fundamentals. Go through tutorials. There's a lot of open tutorials out there from if you're using Terraform, HashiCorp has a lot of stuff. If you're using CloudFormation, AWS has a lot of stuff. Deployment Manager, GCP has a lot of stuff. So and all of it's free. You don't have to pay for an extremely long course or anything like that, and it's easy to pick up. All of this is open source.
Perfect. All right, I think that's it for the questions. Thanks so much, Eric. And just before everyone goes, the next webinar that we have, episode 6, Menlo Security, Zero Trust Environment and Where to Start. So that's on the 21st of August on a Friday. I'll post up the details later on today where you can register for that. So please do check it out. We actually have a special co-host joining us from the cyber riskers community. So don't miss out. So yeah, thanks again for everyone's support. These shows wouldn't be possible without you. Please keep me up to date with feedback and what you'd like to hear in the next upcoming episodes. So Eric, thanks again for joining us and sharing with us your story and your expertise. So please feel free to reach out to Eric if you have any questions, guys, and see you next time.
Definitely. Thank you.
Take care, guys. Bye-bye.
Bye.